Welcome, my beloved Primary 4 students. I'm Mrs. Dua, and this is our fifth and the last chair lesson of Concept 2, Energy and Motion. I'm sure you have seen this model, and you can easily guess what is it. It is a roller coaster. This is the investigative phenomena where we wondered how the roller coaster gets energy to do all the excitement movements. We learned much information about different forms of energy transformations in Learn lessons. And now it's time to collect all the evidence we learned to help us explain the scientific phenomena and to answer the question we wrote down on page 163. This will be in Activity 12, Collect Evidence Like Scientists. Be ready to watch the exploration journey of Ziad and Tariq. And record evidence like a scientist, we will go back to the roller coaster video and we are going to watch it one more time. While watching the video, write down simple sentences and ideas that may help you answer this question. How can you describe the motion of the roller coaster now? Remember that your description must include information and evidence you collected about energy transformations. Let's watch it. Let's watch the video together.
We got ready for our experiments on the Phantom's Revenge by picking where we should use our accelerometers, just like we did with the buttons in the museum.
How about we each pick two things that we think are the most exciting and measure those? Okay, my first choice is the bottom of the second hill, because I think you go super fast and it drops to 228 feet and you feel kind of crushed. I think we'll get a big G-force there. My first choice is the top of the second hill. I think it'll get much more speed from the first hill, and you get butterflies with much more G's. My second choice is a straightaway right after the first hill. It goes super fast as you come down from the first hill, and it curves you as it goes. I think we'll get a little less G's here. My second choice is the huge 180 curve, when it feels like you're going to fly off the track. I think we'll get a good amount of G's, but not as much as my first choice. So you think there'll be more G's at the bottom of the hill, but I think there'll be more G's at the top. Just watch, I'll get more G's than you. Don't count on it. Only the accelerometer knows for sure.
We decided to go on the roller coaster 4 times and write down the results at the end of each ride.
One of my students, Huda, asked me how to write a new explanation for the phenomena. I'll tell you how I helped her organize her ideas to answer the question easily. The first explanation that Huda wrote in her book is that, let me show it to you. The motor and electricity give the train energy to start moving and going up. While the train is going down, it doesn't need electricity because it has stored the energy. The stored energy is converted into another form of energy while the train goes down. Have you noticed that this explanation depends on what you have read in the text on page 162 about the roller coaster? When I read Huda's first explanation for the roller coaster phenomena, I asked her to underline all the sentences that express energy in her explanation, like the phrase, the electricity and motors give the train energy. The stored energy is converted into another form. Look carefully. What is the meaning of it uses electricity? It means it uses electrical energy to start its motion, and it's provided with motor. This means it has a role in pulling it up. What about the stored energy? The stored energy is gravitational potential energy that has been transformed into kinetic energy. Have you ever thought before why the roller coasting is an exciting phenomenon, and why is it related to energy and its transformation? The motor in the rails can pull the roller coaster cars to reach the highest point at the beginning of its motion. Then, all the thrilling movements of the roller coaster depends mainly on energy transformations, speed and gravitational position energy, اللي هي gravitational pushing force. Also, the increase in the roller coaster kinetic energy and speed happen because of the design of the game tracks, which depend on slope and sliding. I think Hoda's new explanation can be: the roller coaster uses electrical energy from the rails. خدتوا بالكم غيرنا كلمة electricity ل electrical energy. And pulling force of the motors which help it climb up the hill. The train store an amount of gravitational potential energy. وهنا حولنا كلمة stored energy ل stored gravitational potential energy until it reaches the highest point. Gravitational potential energy is converted into kinetic energy as the train goes down. Huda may think that when the height and the mass of an object increase, the greater gravitational potential energy it will have. كل ما هيزيد الارتفاع وكل ما الماس بتاعت الترين دي هتزيد، يعني هيبقى أتقل، كل ما الجرافيتيشنال potential energy بتاعته هتزيد، فبالتالي kinetic energy بتاعته هتبقى أسرع. So she can add to her explanation that the greatest gravitational potential energy is when the roller coaster is at the top of the hill, and the opposite when it's down the hill. هيبقى عنده أقل gravitational potential energy. See, it was easy to explain the roller coaster phenomena. Let's look again at the second question. How is your explanation different from before? Look at Hoda's first explanation and the new one. I'm sure you noticed how the two explanations are different now. Hoda can say, I wrote about energy transformations that caused the train motion. المرة دي هي ما اتكلمتش بس على الانرجي، ربطت ده بالانرجي ترانسفورميشن وتحولات الطاقة. I wrote about potential gravitational energy and how it's transformed into kinetic energy. The train has the highest potential gravitational energy at the top of the hill. Now, take your time to answer the questions. The second step in our lesson is to construct a scientific explanation to the question, can you explain? How do moving objects get energy? في can you explain سألنا ازاي moving objects دي بتجيب الانرجي بتاعتها. As usual, we use the claim, the evidence, the reasoning model to organize our scientific writing. لو انتوا فاكرين الطريقة العلمية للكتابة دايما كانت بتبتدي بكليم افتراض وبعدين بنكتب evidence بنحاول نثبته وبعدين الريزنينج كنا بنشرح احنا ليه كتبنا كده. You need to make sure that your claim is one sentence. Your colleagues in my class wrote some claims about the main question. Let me write them on the board. Let me write the question for you. How do moving objects get their energy? How do moving objects get their energy? My students shared some of their claims with me. Let me write them for you. A speeding truck on the road gets its kinetic energy speeding truck on the road gets its kinetic energy from the transformation of the chemical energy in the fuel. From the transformation of the chemical energy in the fuel. My second student wrote, the ice skater moved down by transforming the gravitational potential energy. The ice skater moves down. عارفين يعني ايه الايس سكيتر؟ اللي بيتزحلق على الجليد. moves down by transforming the gravitational potential energy into kinetic energy. And the third student wrote that the potential energy of the tennis player transforms into kinetic energy when he hits the ball. Transforms into kinetic energy when he hits the ball. What do you think? If you look at the question, you will notice that all these sentences are right and they all answer the main question. طب, do I have to choose any one? Yes, let me choose any claim to complete. The claim that I'll choose is the skater moves down by transforming the potential energy into kinetic energy. We can collect evidence from the text, videos, and activities like the evidence in the text on page 170 and page 173, which are about the form of the potential energy and kinetic energy and their transformation. The static objects have potential energy, which means it has the potential to do work in the future. احنا هنا كنا بنتكلم على الايس سكيتر وهو واقف، هو ما بيتحركش، هو ستيبل، فعنده potential energy ومستني ان هو يحول البوتنشال energy دي لكاينيتيك energy. The kinetic energy is the type of energy that an object has because of its motion. يعني potential energy هتتحول لkinetic energy لما الأوبجكت يتحرك. The ball at the top of the hill has a form of potential energy called gravitational potential energy as it may roll down the hill. لو انتوا فاكرين أي object مرفوع عن الأرض بعيد عن الأرض بيبقى عنده gravitational potential energy وبيبقى ready إنه يحول ده لkinetic energy. The energy changes from one form to another easily. Remember when you write the evidence not to explain it because the phase of explaining the evidence is the reasoning. The reasoning is a scientific explanation of the evidence and its relation to the claim. So the reasoning of the claim is the body of the ice skater has gravitational potential energy as he is higher than the ground level. This energy makes the ice skater able to do work for moving down. Doing work transforms the potential energy into different form of energy, which appears in the ice skater motion, and this is called kinetic energy. We are ready to construct a scientific explanation for our claims. Open your student book on page 181. Listen carefully, because I'll tell you the most important elements that must be included. We should first define the kinetic energy and how objects gain it. We will explain how potential energy is transformed into kinetic energy, like the examples we learned in lesson 3. We can also talk about different forms of kinetic energy, like electric energy. Use all these points, then start writing down your scientific explanation. After finishing, I'll share with you another example of a scientific explanation written by your colleague Huda. Huda wrote, kinetic energy means movement from one place to another. Objects in motion have kinetic energy. Potential energy is converted into kinetic energy when work is done. The ball at the top of the hill has potential energy that turns into kinetic when the ball moves down. Of course, you wrote similar points and used different examples from what we studied. We can also see different examples of kinetic energy in different life applications and STEM activities, like the sport I asked you to search about in our last lesson. Do you remember it? Yes, it was the ice skating, or we can call it figure skating, which is one of the winter sports, رياضة التزحلق على الجليد. We will know it in activity number 13, Analyze Like a Scientist. And we are going to explain how this sport is related to the transformation of potential and kinetic energy of the skaters while skating. في كلامنا في الاكتيفيتي دي هنبتدي نتكلم ازاي في الايس سكيتنج هتبتدي البوتنشال انرجي تتحول لكاينيتيك انرجي في different forms في اشكال كتيره من حركه السكيتر. Imagine how the winter sports look like and what is required from the players. Look carefully at the picture in page 182. I think that these sports depend on moving and jumping on the ice. The more the ice skater makes professional movements like jumping very high or flipping, the more they get the chance of winning. Let's know more about this sport while reading the text about Olympic figure skating. Get your pen to underline the sentences which express any form of energy and how potential energy is changed into kinetic energy during the performance of ice skater. عايزاكم وانتوا بتقروا التكست تحطوا لاين تحت اي نوع من انواع الانرجيز هتقابلكم، كمان ازاي البوتنشال انرجي هتتحول لكاينيتيك انرجي في كل حركه من حركات الايس سكيتر. Ice skating is one of the Olympic sports. It doesn't only depend on the ice skater's skills of jumping and skating, but the ice skater should have confidence and strength. This is really important because when they land on the ground after jumping, they should be stable. الايس سكيترز طبعا بيبقى عندهم مهارات كتيرة جدا متعددة، بس من أهمها إن هو يبقى عنده قوة ويبقى عنده ثقة، لأن بعد الجامبينج هينزل على الأرض محتاج إن هو يفضل stable. So they do not fall. Also, they should eat healthy food to get energy for skating. Let's look at this picture. Look well at the picture. When a skater begins to skate to know the forms and different types of energy transformations. Of course, we know that the skater has potential energy stored in her body from the beginning. طبعا جايبة منين potential energy دي? From the food it eats. While doing work, the potential energy in her body transforms into kinetic energy. The kinetic energy and strong leg muscles help her jump high into the air. And at the highest point, the kinetic energy transforms into stored potential energy. اللي هي مين؟ gravitational potential energy، لأن هي بقت بعيدة عن الأرض. Because of its height from the ground, like the roller coaster. This potential energy will keep increasing till the highest point this ice skater can reach. At this point, of course, the gravity will start to pull her back down to the ice, which means that her potential energy will decrease till it transforms into kinetic energy. Let's think of another question. When does the ice skater have the least kinetic energy? And when does the skater have the most kinetic energy? قبل ما نجاوب السؤال ده عايزاكم تركزوا معايا ثانية. الايس سكيتر وهي على الارض وهي بتحاول تعمل جامبينج كان عندها جوه جسمها بوتنشال انرجي جايباها طبعا من الاكل اللي هي بتاكلها from the chemical energy. اوكي؟ when she starts to jump هيساعدها المسلز بتاعتها. طول ما هي بتعلى عن الارض كده جسمها عمال يخزن gravitational potential energy لحد ما هتوصل للهايست بوينت كده عندها الهايست gravitational potential energy. Then she starts to fall down because of the gravity. هنا ابتدى البوتنشال انرجي تتحول لكايناتيك انرجي تاني. Let's answer the question بقى. Look carefully at the picture in which the skater feet leave the ground or the ice to go up and flip in the air. She has the most kinetic energy because while going up in the air, she should move very quickly and push herself forward so she can jump up and flip. We know also that kinetic energy increases when the speed increases. كل ما السرعة هتزيد كل ما kinetic energy كمان هتزيد. Which one of the pictures express the most potential energy? Remember that it will be the picture of the ice skater who is at the highest point from the ground and in the air. عشان احنا متفقين ان كل ما الجيرل كانت بتطلع فوق في الهواء كل ما جسمها كان بيخزن gravitational potential energy. Yes, this picture is number 5. And of course, the image which expresses the least kinetic energy is the one at the beginning of the skating. And now, let's make an easy and simple evaluation activity together. We will look at the pictures in front of us and think about which form of energy these sports have, and which pictures express the most kinetic energy, or which images express the most potential energy. I'll give you some time to write the form of energy which are above each picture and circle the most potential energy with a pencil and the most kinetic energy with a pen. البوتنشال بالبنسل والkinetic بالpen. And I'm going to prepare it for you. I prepared the pictures here for you. Let's look at the pictures one by one. The picture in which the ice skater stands has potential energy. Here, the ice skater stands, so it has potential energy because he didn't move. The picture here shows the kinetic energy because the skater is turning around. In the second picture, here it shows kinetic energy because he is turning around and moving. And the third picture is same because the girl moves down the hill. في الصورة دي البنت بتتحرك لتحت وطالما قلنا كلمة move يبقى it's kinetic energy. The last photo shows gravitational potential energy because the ice skater is far from the ground. Of course, you now discovered the picture which has the most gravitational potential energy, which is, yes, this one. The one with the ice skater at the highest point far from the ground. The highest kinetic energy is the picture with the girl because she is going down the hill. الاثنين دول فيهم kinetic energy بس هنا بيتحرك straight وهنا بتتحرك على hill. هنا سرعتها أكبر فأكيد هيبقى عندها more kinetic energy. The last activity in today's lesson is activity number 14. Let's do it together. Activity number 14, evaluate like a scientist. In this activity, we will write a summary about the most important points we knew about the energy and motion concept. On page 185, you will write the different forms of energy you knew, their types, and how the energy concept is related to motion. You can use all the information we knew and reviewed to write your summary in main points. You can share these points and summary with us by scanning this QR code on the screen. Just ask your parents to help you take photo of the page you wrote and then upload it. Don't forget to write your name, school name, and governorate. You can use this table. Do you remember the association table? In which you wrote down all the key vocabulary related to the different forms of energy that we learned in this concept. In this table, you also wrote down different forms of potential and kinetic energy in the other table. في أول تيبل كتبنا كل أنواع الانرجي اللي احنا قابلناها، وفي تاني تيبل ابتدينا ننظمهم لكايناتيك وبوتنشال انرجيز. تقدروا ترجعوا لهم وانتوا بتكتبوا السمري بتاعكم. Let's now answer some questions to check our understanding of the whole concept. Don't forget that you can go back to any part you need to understand more about at any concept we studied together at our YouTube channel, مدرستنا. Let's answer the questions. Let's see the first question. When gasoline is burned, stored chemical energy is released in the form of A and light. الجازولين اللي جوه العربية لما بيتحرق بيطلع light و A، بيطلع light and heat energy. The answers fumes, carbon dioxide, sparks، ولا حاجة في دول is a form of energy أصلاً. Question number 2. You toss a ball into the air. The ball falls and then bounce back into the air. What happened to its energy? All of the energy remains unchanged. More energy is created as the ball bounces off. Some energy is destroyed as the ball bounces. Some energy changes to other form of energy. لو فاكرين واحنا بنشرح ركزنا قوي على ان الانرجي is neither created or destroyed. فcreated and destroyed both of them they are wrong and energy will not remain as it is لأن الكرة طلعت ونزلت فالenergy أكيد اتغيرت. So some energy changes to other forms of energy. Question 5. Which ball has kinetic energy but not potential energy? A ball rolling down a ramp, a ball sitting on a high shelf, a ball bouncing up and down, a ball rolling on a flat sidewalk. The answer is D. Question number 6. Which type of energy change occurs when a person rides a bike? Heat energy changes to potential energy. Chemical energy changes to kinetic energy. Solar energy changes to chemical energy. Kinetic energy changes to nuclear energy. مبدئيا احنا ما اتكلمناش عن nuclear energy ولا solar energy. So we are between A and B. أنا جوه جسمي بيبقى عندي heat energy ولا chemical energy? Inside our bodies we have chemical energy from the stored food. So chemical energy changes to kinetic energy. This is the right answer. The last question. Which of the following can store energy? Battery, wire, plastic, rubber. Can store يعني جواه potential energy. The right answer is A because battery stores chemical energy. Does any one of you think before how all the information we learned in the energy and motion concept will help us design a tool to keep the drivers safe? You can think about the dummy we saw in the unit introduction video and how it moves forward strongly when it hits a barrier or a wall. Of course, different transformation happen to energy while the car moves or during collision. Think of car's energy during its motion. And what are the transformations that happen during the car collision? You can discuss your ideas with your classmates and share some of the information you learned during the concept. Speed. Speed must be one of the most important topics you will think about and start talking about in the investigative phenomena. How is speed important in understanding the anchor phenomena? The science of car crashes. You will know more in Concept 3, Speed. Don't forget to review your lessons well and send us any questions you have to مدرستنا Facebook page. Thank you, my dear Primary 4 scientists, and see you the next time.